Okay, hello pre-calculus scholars. Today's notes are going to start on page 5 of your handout where it says 2.6 notes at the top. So these notes, we're going to connect what we did at the beginning of class today, which had to do with average rate of change. And we're going to connect this idea to kind of the culmination, the end point of Unit 2 and of the semester, which is this big idea of concavity. So all of today's notes are going to fall under this category of concavity. Okay, so what does concavity mean? So a function is called blank if its average rate of change increases from left to right. So we know average rate of change from the beginning of class today. We reviewed that this is the same thing as slope, which is the same thing as change in y over change in x. We practice calculating that as y2 minus y1 over x2 minus x1. So what does it mean for a function if the rate of change actually increases from left to right as x values get bigger? What we call that in math is concave up. This is a huge idea for the rest of calculus and higher math. You'll hear functions talked a lot about as concave up. The opposite of that, you might be able to guess, would be concave down. So a function is called concave up if its average rate of change increases from left to right, and a function is called concave down if its average rate of change decreases from left to right. So looking at a function, it's actually pretty straightforward to tell if a function is concave up and concave down. You actually, throughout your whole math career, have already seen many functions that are either concave up or concave down. You just didn't have the vocabulary yet. So on the left here, we're going to draw an example of a function that's concave up. What that looks like visually on a graph is it looks like a bowl. So some people like to think of a concave up function as being like a bowl sitting on a table. I personally like to think of concave up as being like a smiley face. So if you draw eyes here, concave up is always going to look like a smile, which is a good way to help remember. And this, again, this function is concave up. And we know that concave up, what that must mean according to the definition, is that average rate of change increases from left to right. So let's just quickly say rate of change, sorry this is messy, increases left to right, which we'll see what that looks like in a table in just a moment. Concave down is the opposite. It looks like a frown. So that can be helpful, like a helpful phrase to remember these shapes. Concave down looks like a frown. It's like a little rhyme. Concave down looks like a frown. If you were to draw two eyes, concave down looks like a frown face. Again, some people prefer to think of concave up as like a bowl and concave down like a hill or an upside down bowl. Whatever works for you to remember those shapes. This is definitely something to like put on a flashcard to just memorize the difference between what concave up and concave down look like. And from the definition, we know concave down, according to this definition here, means the function's average rate of change decreases from left to right. So what this actually would mean in practice is that the rate of change decreases from left to right. Okay, so other than the shapes of the graph, it gets a little bit more complicated when we add another representation, which is a table. So let's see how to tell if a function is concave up or concave down from a table. So this is the type of problem you'll be doing on your problem set this week, as well as your exit ticket today. And on your final exam, this would be the type of question I would ask about concavity. So consider the function below, fill in the table, and then decide if the function is concave up or concave down. Okay, so a helpful thing to remind myself, since I'm just learning this, what does it actually mean for a function to be concave up or concave down? Well, I don't have to have that memorized. It's right at the top of my paper. Concave up means the rate of change is increasing. Concave down means rate of change decreases. So let me just remind myself. Concave up, I'm going to say rock, just short for rate of change, increases. And concave down would mean the rate of change decreases. Okay, so I have a few different things I can do. The first is I actually have a graph of the function, and I know that if a function looks like a smile, it's concave up, and if a function looks like a frown, it's concave down. So this is not a perfect smile, but in general, if I were to draw like a little eyes here, I would ask myself, does this look like a smiley face or a frowny face? It looks like a smile, so it's concave up. So before I even do any math over here, I can already know, I already can determine that the function's concave up just from looking at the graph. But then the question becomes, what if I didn't have the graph? Like, what if I only had these numbers over here, which these xy coordinates match up to points on the graph. So it's the same function, just in two different representations. How could I tell just from looking at this table that the function is concave up or concave down? Which we should be able to do by the end of class today without a graph. So, luckily, I was strategic about this, and we filled out the same type of table all in the beginning of class today. So we should be all set to find the average rate of change between all of these points. So from 0 to 2, the change in x is plus 2. And then from 0 to 50, the change in y is plus 50. So I'm going to go ahead and calculate the average rate of change in this part of the table, or change in y over change in x. It looks like my change in y from 0 to 50 is a plus 50, and my change in x from 0 to 2 was a plus 2. So the average rate of change is going to be 50 over 2, which is 25. Okay. The next part of my table, I'm going to do this in a different color just so you can kind of see that this is a different mathematical operation. That's the reason I'm using a different color. To get from 2 to 3 is a change in x of plus 1. To get from 50 to 100 is a change of plus 50. Again, I'm using my AROC, my rate of change equation, change in y over change in x. How much did y change? It changed by 50. And how much did my x change? It changed by 1. So this time the rate of change is 50. For the next jump in my table, the rate of change is 50. All right, for the next part in my table, from 3 to 5 is plus 2. From 100 to 300 is plus 200. So my change in y, using this equation again, is 200. My change in x is plus 2. 200 divided by 2 is 100. Okay, so I'm going to end up with 3 rates of change, which is similar to, this should be familiar from the beginning of class. If you have 4 entries in the table, you're going to end up with 3 rates of change because you have 3 jumps, 1 jump, 2 jumps, 3 jumps. So you should end up with 3 rates for 4 table entries. Okay, so now I have all of my rates, 25, 50, 100. And now the question is, how can I use this information that I've just calculated to prove that if the function is concave up or concave down? I already know it's concave up from the graph. And according to my definition, a function is concave up when the rate of change increases from left to right. So hopefully you can see from left to right, the rates are going up. So 50 is greater than 25, so that's a positive change. 50 to 100 is a positive change. So in general, from left to right, these numbers are increasing. The rates are increasing. So here's the key. For this type of question, your final answer is going to be a full sentence. And the structure of that full sentence would look like this. You would say something like, this function is concave up because, and what's the reason it's concave up? We need to use the definition, which is rate of change is increasing from left to right. So we'll say because rates of change are increasing left to right. So you'll want a full sentence using all of the rich vocabulary words that you know. Concave up, rates of change increasing left to right. And then you'll also need to show your mathematical work as evidence for your final answer. So as you work through the example problems, make sure you write a full sentence for each problem and make sure that you structure it in this way using all these vocabulary words. Okay, one more example. So this problem is from your textbook, and it is about salary. So what this graph is basically showing is how someone who works in a corporate job, how their salary increases over time. So a corporate job would be like if you're working for a large company. And in general, for most companies, this is how your salary looks over time. This is very typical. And in general, just an interesting application of this idea of concave up. In general, say salary is concave. And by the way, salary is just a fancy word of like how much money you make. So you're working at a certain job, your salary or how much money you make tends to be concave up over time. So what does that mean? Okay, well in general, it means that your salary is increasing over time. You're making more money as time passes, which is a good thing. You want to be making more money as you work for a company for longer, not less money. What it also means is that the rate of change or the slope is increasing over time. So the rate of change increases from left to right, meaning that at the beginning, so like in the first 10 years that you work for the company, you might have a small increase in pay. So maybe you'll be promoted from like just a general employee to like an assistant manager or something, which would be a small pay increase. But as you move up the corporate ladder, so as you get more and more promotions, the rate of change actually increases. So what we tend to see in pay structure is that towards the end of someone's career, they start to get big, large raises. So maybe they're promoted to be like a general manager or a CEO, or they have a high-up position in the company. So towards the end of your career, you start to see these drastic pay increases working for a big company. So a good thing to know if you're interested in working for a company or having your own company someday. Okay, I'm going to fill out this table using the points on my graph. So after 10 years working for this company, I'm going to estimate it looks like I make about $100. Or sorry, this is in 100,000s. So I make about $100,000. It's a pretty good job. And then it looks like after 20 years, let's say that's 120. Again, I'm just estimating here. 30 looks like about 200, and then 40 looks like about 400. Okay, I'm going to go ahead and calculate my rates of change. My change in y here is plus 20. My change in x is plus 10. So my rate of change is 20 over 10, which is 2. Now I have plus 10 plus 80. So my rate of change is 80 over 10, which is 8. And then for my last one, in 10 years, I make $200,000 more dollars. It's a huge change in y is 200, and my change in x is 10. So it's going to be a rate of change of 20. Okay, so is it concave up or concave down? From left to right, are the rates increasing or decreasing? From left to right, the rates are definitely increasing, meaning I'm definitely making, my pay is increasing at a faster rate as I work for the company longer and longer. So not only am I making more money, but I'm actually making more money in less time. My pay is being increased more rapidly the longer that I work for the company. Okay, so my final answer, I'm going to write my full sentence. I can say, I'll be specific, I'll say the salary function is concave up because rates of change are increasing left to right. And that's always true, or normally always true in economics. Salary functions always tend to be concave up. And we could double check my graph. Does my graph look like a smile or a frown? Definitely looks like that, the curve of a smile face. So I can make sure that my math is right by looking at the graph and seeing that it's concave up indeed. Okay, so you're gonna go ahead and try 3 example problems on your own. They start on the next page. The answer key is posted on the home page. So try these problems, check your answer key as you go. This is a great time to ask questions of me and of your partner because we're gonna take an exit ticket in about probably 10 minutes from when you finish this video. All right, thank you for your attention.